So in Hess's law, we can manipulate some chemical equations to get the enthalpy. Remember enthalpy? This is change in enthalpy, which means heat flow. So we can get the enthalpy of an unknown reaction if we know the enthalpy of some other reactions and we do some manipulations. Okay. So what type of manipulations can we do? Okay, number one, we can flip a reaction. So if you flip a reaction, then the delta H changes sign. Okay, from positive to negative or negative to positive. Or you can multiply a reaction by some number n. Okay, the delta H resultingly gets multiplied by that delta n. So those are the two things we can do. So let's check out this problem. Okay, we got N2H4 plus CH4 goes to CH2O plus N2 plus 3H2. Okay. So in this problem on the test, problem on the quiz, problem on your homework, okay, we want to know the delta H of this reaction, the enthalpy of this reaction. Okay, remember, if it's positive, it's endothermic. If it's negative, it's exothermic. So we don't know this. Okay, but what we do know are the enthalpies of these three reactions. Okay, of these three reactions. So what can we do with these three to get to this? Okay, what can we do with these three reactions to get to this? Okay, we can flip a reaction, we can multiply a reaction. Okay, there's several things that we can do. So let's start off with, you see N2H4 here. Is it in the reactant side or the product side? Okay. It's in the reactant side. Okay. Where do we see N2H4 here? We see it here, but it's on the product side. Okay. For this reaction, that's 22.5 kilojoules. So what can we do to this reaction to get it on the reactant side, which is what we want here? Okay. We can flip it. So what we can do is we'll flip reaction 1, or flip the first reaction. Flipping this so that this can be on the reactant side. So I'm going to flip the first reaction. All right, so flipping it, the N2H4 liquid plus H2 gas, okay, goes to 2NH3. Okay, so if we flip this reaction, okay, now see what has happened. The N2H4 is now on my reactant side because that's what we want. So what will the corresponding delta H be? So we flip the reaction. So what happens to the sign of the 22.5? It changes sign. Very good. It becomes minus 22.5 kilojoules. Okay. All right, what else can we do here? Okay, so you see this CH4O. Okay, where do we see a CH4O? Okay, we see it, but it's on the product side. Okay, what can we do with this third reaction to put it on the reactant side? Yes, that's correct, David. We can flip it. So we will also flip the second reaction. Let's go ahead and do that quickly here. CH4O liquid. Okay, this is going to CH2O gas plus H2 gas. Okay, so now our CH4, just like the N2H4, is in the reactant side. Okay, so for 2 for 2 here. And what will we do here to this delta H now that we flipped it? Yes, sir, we'll change the sign to minus 81.2 kilojoules. Okay, so what I'm going to do now is I'm going to add these two reactions that I flipped, because if I add them, I'll get this in the reactant side and this in the reactant side. So let's add the flipped reaction 1 with the flipped reaction 2. So add the above two reactions. Okay, when you add two reactions, what will you do to their corresponding enthalpies? Okay, you also will add them, right? You also will add them together. So let's add these. Okay, do you see anything that cancels out, you guys? Okay, what do you see that cancels out? I see an H2 on the reactant side that cancels out with the H2 on the product side. So they have canceled out. And now we have N2H4 plus CH4O goes to 2NH3 plus CH2O. Okay, so now all of our reactants match all of the reactants on the reaction here that we want to calculate to delta H4. So what is the corresponding enthalpies? We add them up, right? So what's minus 22.5 plus a minus 81.2? 3 minus 113.7 kilojoules. Okay, that's the delta H of this reaction.
No, it's 103, not 113.
103.7, thank you. Okay, so now what do we have left? We have a CH, let's go back up here. So these two are good. I have a CH2. Oh, I have a CH2 on the product side. I have a CH2 on the product side. Isn't that good? Okay, so now I need an N2 and 3H2 on the N2 and 3H2 on the product side, and here I have an N2 and 3H2 on the product side. So what can I do here? I can take this reaction and I could add it to the second reaction. So now we'll add the second reaction. So we don't have to multiply anything. We don't have to multiply by 2 or 3 or 4. So we will add the second reaction here. We don't even have to flip it. Okay, we don't have to multiply anything. We don't have to flip anything. So if this becomes 2NH3, okay, which goes to N2 gas plus 3H2 gas. And this is at 57.5 kilojoules. Okay, so what cancels out here? Okay, this 2NH3 will cancel out with the 2NH3 there. And then we're left with N2H4 plus CH4O. N2H4 plus CH4O goes to CH2O plus N2 plus 3H2. Okay, it goes to CH2O plus N2 plus 3H2. Right, and I think this is our answer, so it'll be N2H4 plus CH4O goes to CH2O plus N2 gas plus 3H2 gas. Okay, so what is the delta H of this reaction? Okay, we add the two reactions. We get the reaction that we want here, and we add the two enthalpies. What's minus 103.7 plus 57.5?
46 point.
Negative 46.2. Thank you, Husong. Negative 46.2. So this is our answer. Okay, so this matches that. By flipping and multiplying, though we didn't have to multiply anything here. Okay, this has matched this. And it becomes minus 46.2 kilojoules. So this is our answer. Alright, so this is how you do a Hess's Law problem. So be careful, because sometimes you may have to multiply a reaction by 2, 3, 1/2, whatever it is. Okay, we didn't have to, but sometimes you may have to multiply a reaction. If you multiply a reaction, what do you do to the delta H? You multiply it 2 as well. Okay?
The multiplication is only by the number that is in the first, then the reactants, or the first.
Say again, I'm sorry.
When you have to multiply by some number, it's because it's the first number of the reactants.
Or yeah, whatever. If there's a number here,
Right.
then let's say there was a 2 here. This example doesn't have that. Let's say there was a 2 here. Then there's a 2N2H4. You'll have to multiply this reaction by 2 to get a 2N2H4. Yeah. Yeah. When we have a review, I'll do an example problem where you have to multiply. But in this case, we just shuffled things around so that we get this to match that. All right. Are there any questions on this? All right. So that is that's a wrap of chapter 6. So we are done with chapter 6, and now chapter 6. Yes. Okay. So now let's go to chapter 7. Okay, we'll go to chapter 7.